So, hello guys, it's me Franz Kingstein with yet another video of artificial intelligence. So, in this video, we're going to learn about using artificial neural network in order to not predict value, in order to find a house price using regression. So, we uh, mm, we usually use artificial neural network to classify the models, but this time we're using artificial neural network in order to predict a continuous value or to perform regression on a particular data set. So before entering into the topic or before entering into the code, let us get into some theory concepts so that it might be easy for us while we code. So here we go. So yeah, this is a small summary of what is artificial neural network. So artificial neural network is a correction of node and edges, which act as a neural network which is in a human brain. So as we know that a human brain system consists of multiple neural networks, and each and every task that performs on our brain is carried out using uh, neural networks. For example, even the thinking part, the cognitive reasoning part, etc., logical thinking even, and these things have been done using the neural networks. In order to simulate this, people try to make the computers to think like human, right? Simulating or performing mathematical calculation that could uh, act as a real neural network. So this is how a neural network used to be visualized in terms of computers, but usual computers doesn't have this inside, but instead they have code and pointers and numbers and mathematical functions into it. So this is about artificial neural networks. Some of the key concepts which we use in artificial neural networks are loss functions. So let me tell you the flow first. So first, in artificial neural network, we just start from the input, then we get into the hidden layer, and we find a predicted value, that is a particular value. This is a forward pass using activation layer. But if the value has some error, no, we should go in a backward direction, then correct the weights which should be inside each and every edge is being counted the nodes, and in order to get a better accuracy. So first steps usually follow an artificial neural network, that is forward pass, that is from input to the output using the activation layer, that is second. So activation layer it just make sure that if a particular node should be active or should be hidden or should be completely put on sleep at that particular time. So that is the two steps. The third step is finding the loss function. What is the loss function? It means it's a difference between the actual value and the predicted value. The predicted value is the thing which is being it's given by this artificial neural network, and the actual value is the real value that the data set or the real value that should be exist. So we find a difference between them, and using this difference or loss function, we just go back from output to the input lower. That is called as backtracking. But we keep on updating each and every weight of a edge in order to make the smaller to predict more accurately. And so some of the parameters that we use here are loss functions. So this is what I asked. I told you the difference between the actual value and a predicted value. And in regression tasks, we use some parameters like mean, absolute error. We not only find the difference, but we also find the absolute value of it, and we just make it as a mean. That is, we find the average over it. But and also MSE, that is mean square error. Instead of finding the absolute value of it, we just square the value, then take the mean of it. The reason why we use a mean square error is the error would be enlarged or zoomed, or it could be more visible, like what is the error, and it will enhance the error more clearly for more to understand. So what is the optimizer? Like after finding a loss or after finding the difference between the actual mean and predicted value and finding the mean, absolute, or the squared value, we go back, say that is the backtracking, right? While we are going on backtracking, we say that we should update the model with respect to a particular penalty or particular value. This value is being created, it's been maintained, optimized using an optimizer. And here we are using an Adam optimizer. So as Adam optimizer is, it is a combination of RM plus prop and momentum. So yeah, so what is the momentum? Momentum is how the learning curve learns toward the time. With some data, the backtracking model or backtracking step will be optimized in such a way that the sleep curve or the learning curve should be a particular shape where the model learns well. What is RFS for? It's root mean square error, where we use the same function of the loss, but instead of this finite difference, we just use it for updating the weights. So what is the activation function? It is used to learn complex pattern according to this. But activation function, as the name suggests, it activates or deactivates a particular node based on its input or based on the value. So this could be used in order to give a model a non-linear. This instead of just going input, output, and input, hidden, and output, it hides a deactivates some layer in order to perform complex or non-linear calculation. So what does an approach? A number of times the model sees the entire data set. So we used to train the data, right? So as we perform the 4 steps, so how many times we are performing these 4 steps has been called as the neighbors. So what is the matrix? So we know that matrix is the loss function, which could be used for saying that whether the model is predicting accurately, or is the model correct, or it has any errors. This could be checked using this matrix. So without any further delay, so let us go directly into the coding part. And yeah, so this is how our coding goes. So before getting into the code, we are going to see what this actual problem statement is. So we used to see in OLX and some places where people would be finding a bit difficult on setting the price, or just keeping a particular price, or the people who want to get rent, like they want to see how the price goes. So what are parameters of features that increases the price or decreases the price. So in order to make up calculation with respect to house price, by just creating a regression model in such a way that it could predict the value of the house continuously, so that people would be, find it better to understand how the price goes, whether it goes up or it goes down, and they could make better choices with it. So as usual, as we are using the Python code, we use the import model like pandas. Pandas is for putting data frames and handling data in a better way. We also use TensorFlow, which is it's a library as well as a framework. And I said a lot of times why TensorFlow is called as library and framework. Library in the sense it contains many pre-written codes, so that you could easily import it and use the methods to perform calculation. And it is a framework because it contains high-level APIs like Keras. So we're using from TensorFlow importing Keras, and from Keras we're importing layers, that is a neural networks which is going to work. Then we also importing a thing called train cluster. So what is this? So we have a set of data, but instead of making the entire data set only to make the model learn, let us keep the ratio 70 and 30 in such a way that the 70% of data should be used only for training purpose, only for the model to learn the pattern or how it should predict. The 30% of data should be used for testing purpose. That is how the how the model performs well, and we use this test data to find accuracy, mean square error, absolute mean square error, etc. And now let us get straight into the next import statement called sklearn kit. So sklearn is a library which contains very few written codes for simple machine learning machine machine learning algorithms like KNN, K means less sitting, random forest, linear regression, etc. It also contains evaluation matrix or matrix that could classify a matrix that could evaluate a particular model. So we're using confusion matrix in order to check how well a model predicts using a test data. And we're also using matplotlib in order to visualize how our accuracy is. And I'll just tell you why we're using matplotlib, for which type of grad, and what are we using it. So our next code contains we're just importing it from GitHub user content, because it doesn't have in Kaggle or directly in Keras, because the this dataset has some issues in it, like the privacy and some issue regarding it. So it has been deprecated from version 2 or 3 of Keras. So it is importing it directly from GitHub. And we also using pandas with CSV format. Since the data has been written in CSV, I just reading it at a function called read CSV. So now we're just splitting the data into X and Y. What is X and what is Y in this sense? X is the features of a particular value. For example, house. No, it can have the number of rooms, the area in which the house is being located, how many is it in the first floor or second floor, etc. So these are the features which could help us to predict a particular value. With these features, we can say it is a 10K house or a 20K rental house using this value. We say this 10K and 20K. These are Y values, that is the expected output, or we just call it label in terms of the scoring. So we use this X data into the model so that we could predict Y. So we're also splitting X test and Y test, as I said before, using this train test split in order to make the model train with 70% of data and to test the model with 30% of data. So let us build the model. So we use a sequential architecture because as I said before, this model performs a sequential first input layer, then hidden layer, then output layer. So this is the sequence which usually artificial neural networks follow. And since we are using sequential model from Keras, so from sequence we use layers as being imported called dense layer. What is a dense layer? It is an artificial neural network containing many nodes and many edges connected to it. Like each node we connected with the next node, and there is no node it shouldn't be connected. In this sense, each node of one side will be connected with each node in the other side. So this is what a dense layer does, and this is what a dense layer is. And we use the 64 nodes in it, and using activation layer called ReLU. So as I said before, activation layer is to activate a particular node, whether it should perform or whether it should participate in this regression or in this mathematical function are not is determined by ReLU. So what is a ReLU? ReLU is it's a function. It's in such a way that it has only two, it gives only two output, whether 0 or 1. This is being used in order to evaluate some noisy values or some misconfusion in the predicting value. So it also give input shape as x of key of n, because the model input should be such a way that it should match with the key features of the XTL, that is the key features of the features. Okay, so next is a hidden layer. So this is we also using dense layer with the same 64 nodes, and activation is ReLU the same. So next is the output layer, which we have only one. Why one? Because the output contains only one layer. It could say 0, 1, or the one. This is the only node which can be, which must be used for saying whether what is the price of a particular house, etc. So I was comparing it to an optimizer called Adam. So as we said before, we're using optimizer Adam, a loss equal to mean square error, which is being said in the theory concept, and we're using metrics, like metrics in the sense on the loss function we're using mean square error. It was using mean absolute error in order to continuously check whether it is being correctly classifying or not. So we are fitting the model with X train, Y train, and we using approach of 10. That is, we are just reading the entire dataset for 10 times in order to increase the efficiency, in order to increase the accuracy of the model. So we use batch tries in 32 in a sense. We are just not sending the entire data as such, but instead we are just splitting into 32 size, and we're just importing it in a model. So it doesn't have overhead in it. So this is how reports goes, and my final accuracy, not final absolute error, is 2.403, and it's a good accuracy for 10 approach, 10 approach. So if we go more approach, in a sense, we can get even more good mean absolute value. So as I said before, we use matplotlib in order to plot how the mean square error, mean absolute error goes over approach. So this guy is going like dancing up and down, saying that I can't go anything. But this is how our model has been trained, where this is not very stable. So sometimes the accuracy goes down, sometimes the accuracy goes very high, and it is like a zigzag pattern. So this is what a regression model is, and we use this regression model in order to predict the price of a house. So I hope you might enjoy this video. If any doubts, you can definitely comment me, and tell us any mistake, please forgive me. So thank you for seeing this video very patiently. Thank you. Bye.